Most of the time, bacteria in its so-called planktonic state is quite simple to deal with. The real trouble occurs when the bacteria forms a biofilm. The advanced structure of the biofilm makes it 1,000 times more resistant to antibiotic treatments than when in the planktonic state. Biofilms are especially dangerous when dealing with biomedical devices such as hip implants. The surfaces of these devices are designed to enhance the adherence of desirable tissue cells, but are unable to inhibit bacterial biofilm growth.
Advancing biomaterial services to distinguish between desirable tissue cells and undesirable tissue cells is the holy grail of my research. Currently, I am working on development of three-dimensional models of bacterial biofilms to interrogate the effect surface topography has on their adherence properties.
Kyle's been working on this project long before the summer started. He's actually one of 7 Stevens undergraduates who are working on something that we're calling the IDL, the Innovation Design Laboratory experience within the Laboratory for Multi-Scale Imaging. And these 7 undergraduate students are working on 7 different projects, all of which are very microscope intensive.
I'm using a state-of-the-art microscope married with traditional biological specimen preparation techniques to create a set of serial images. Using the advanced visualization software of EasoFire, I am then able to render them into a 3-dimensional model. In these past 6 months, not only have I received thorough microscopy training, but I've learned how to culture bacteria, preserve biological samples in an epoxy medium, and create 3-dimensional models that have a quantitative as well as a qualitative use. Throughout the summer, I've worked on creating a baseline for comparison by growing Staphylococcus aureus on a polystyrene petri dish. Throughout the fall semester, I am looking forward to varying the topographies of the surfaces the biofilm can grow on, as well as investigating cryogenic preservation techniques.
We try to bring the young mind to work on the complex issues, and then with the new ideas, hopefully we solve those complex issues in a faster time frame. Hopefully we give you enough training or bringing you early enough that you can certainly making a difference. So that's what I think the ideal program really set up the example on how we can achieve that goal.
I think one of the coolest experiences here is that I get to work with the SCM, and it costs over $1 million. I'm one of the happy few that actually get to use it.